AI will basically go look at all these databases and look at, hey, what kind of products do you need? What kind of materials do you need? What kind of use environments do they need to be in? And help those customers down select to the appropriate material and process. So basically, it's bringing our new composite-based additive manufacturing system to market to key verticals, electronics, and then for the unmanned systems markets. The main feedback that we're getting from our customers at Impossible Objects is that they want a system that's repeatable and that's capable of mass production. Our technology is based on robust 2D printing technology that prints at very high speeds with repeatable results. And so we're just building on that base knowledge of 2D printing. As far as the talent in the industry, I think that can be done on multiple levels from my perspective. Number one, like America Makes, is doing a lot with workforce development. There's programs certainly within Society of Manufacturing Engineering that's doing that. Fab labs across the country are teaching the younger generations the principles of additive manufacturing and 3D printing, as well as various schools and research institutes across the country. We have a lot of options for the end users in this market out there. And just in the last 5 years alone, like the explosion within like the extrusion processes. I think the good ones will bubble to the top, and the ones that are not so strong will kind of either fall out. And that will help make better decisions for people determining what process to go with. Well, I think short term is that with all these different material and additive processes that are available to the customer base, is that AI will basically go look at all these databases and look at, hey, what kind of products do you need? What kind of materials do you need? What kind of use environments do they need to be in? And help those customers down select to the appropriate material and process best suited for their products. So I think it's already happening, certainly in high value AM processes such as direct metal. All the ASTM standards that's being generated and developed under various types of Department of Defense grants, Department of Energy grants. And so they have built the framework of saying these are the standards that if you want to apply it for high value products, and then just basically take that framework and replicate to other processes. So what we're doing as a small tech company is that we have design guidelines, and we have that we share, and we talk with our prospective users, and getting those design guidelines out, understanding the design build limitations of the technology, I think is really important to help accelerate and educate the community. Because I think that we're going to start to see more adoption of additive in the medical community, prosthetics, orthotics, exoskeleton types of suits. Going forward, I also think that there's going to be opportunities like in electric vehicles with some of the componentry that's going into EVs, and then certainly the company I'm with unmanned systems, is going to be a big sun-rising application area. With what's happened over the last couple of years, I think people are beginning to realize that, hey, there is a lot of work holistically that you have to do from design, build, and inspect. That takes longer. And if you're going to transition that to other types of products, that people have now been level set to what the reality is. What makes a champion of additive manufacturing within a company? I think it's two skills. Number one, it's being kind of a technology scout. And number two, kind of taking a systems engineering approach from start to finish to end of life of products. It continues to grow every year, and I think with the advent of kind of bringing manufacturing back to North America, I think that this is going to be a great technology that will help many different industries accelerate getting their products to market with greater efficiency.